Hello, Legacy students, Marsh here. So today we're going to talk about variables in regards to Java. Um, we kind of already have talked about variables and what they are, but all they are is just an area of memory that holds data that can be modified throughout the program. So think of it as a box in which that we can place information inside. And that box might be pretty small or it might be pretty big depending on what kind of variable we're using. The names of the variables must be very descriptive. Try to not name it Bob1, Bob2, Bob3, because you're not going to remember what Bob means. A variable can be any valid Java identifier, so that can be anything, but it cannot be a keyword. And what I mean by keyword is, let's say, like public. It's a word that's going to turn blue. Those are the words that Java holds on to them for his own special information. So be careful when you name a variable. If it turns blue for the name, that isn't problem. You cannot use a word in a variable that turns blue. They're usually going to begin with a lowercase letter to distinguish them from their class names. And classes usually are named, or the program is usually named with a capitals letters, okay? And then a variable must be declared before it can be used. Not of all languages have that, so Java is very particular in that regard. So, what can a variable declaration and what does it have to include? Well, a declaration is just me shouting off on the rooftop saying, I'm making a variable. Okay, that's all a declaration is. But what do I have to include? I have to include the data type that identifies the type of variable that it will store. So is it going to be holding numbers? Is it going to be holding numbers with decimals? Is it holding words? Is it holding letters? What is it holding? Identifier, that's the variable's name, so I have to have some kind of name for the variable. An optional assigned value when I want to give it an initial value to start with, and then an ending semicolon. So here's my example. I have int my age equals 17. Now, those of you that have taken programming 1, that's not that difficult, right? In Visual Basic, we had to make variables and we had to get data types. Now, those of you that have taken principles before, in JavaScript, you didn't have to give it a data type. JavaScript was very nice in the regards of we didn't have to do that. However, we're not that lucky in Java. Java's a little older, so he requires you to tell him what kind of data type you are expecting to be given. Here are the 8 primitive, aka simple, data types that are available in Java. There's Boolean, byte, char, double, float, int, long, and short. Now, keep in mind the kinds that these are. You're going to find that byte is not often used. That one you do not need to worry about in this class. Float is not very common either. Float is the same as a double. It holds about the same kind of information. It's basically decimals. And then these guys right here, int, long, and short, those guys also hold the same things. Long and short are not commonly used in this class. However, be aware that those are available as a programmer. Each of them just hold a certain amount of a number. So the bigger the number, the smaller kind of idea. So the ones that you're mostly going to have to be using in this class are Boolean, char, double, and int. So let's take a look at those. Int is used to store integers, either positive or negative. So this means no decimals, okay? These guys are the no decimal club. So here's some of my sample code. I got my public static void main, string bracket bracket args, and then I made a variable right here. So I'm declaring him an int. I'm saying his name is age, and it is set equal to 59. So this is me initializing this variable. I'm giving him a value to start with. And then I print out age. Well, what's going to happen is when I create age in the memory of the computer, so this is memory computer. Okay, there's going to be a box that's made, and it's going to know that that box is named age, and inside of that, it's going to place 59, because that's what I told it to do. So when I system.out print line age, it's saying, the computer is going to go, oh, she wants the number for age. It's going to go over to the box. It's going to open the box. It's going to see there's a 59 in there, and it's going to print 59 to my console.log. So thinking that in that form, what we're doing is we're basically storing the number 59 inside of a variable for future use. The next one is a double. Double is used to store floating point numbers, so decimals. So this is the people that can hold a decimal in here. So I can go public static void main, double D equals negative 1.37.088036. And then I print out D. So again, if I'm in the memory and I make a variable called D, and then I'm storing that number inside. So I initialized him to be that value. Notice I am telling Java immediately this is a double. You need to do that when you make the variables. You can't just make them on the fly. They have to be told what they are. And then I would print out that number to my terminal IO, my console. Now notice you can do scientific notation, that is available. So if I want to do scientific notation, I would put the letter E in it. So what that would do is it would store the following. It would be 667 times 10 to the 23rd. You might have seen that in, let's say, a science class or maybe Algebra 1 as well. So that's the idea that you can do scientific notation as well in these programs. CHAR. Now, CHAR can contain a single character. That's why it's called a CHAR, short for character. To declare, it needs to look like the following. So we're going to say, hey, I'm printing out a CHAR. Okay, that's what I want to store. His name is CH, and I'm storing into CH an H. Notice the single quotation marks. That is different because it's a CHAR. Now, if you would put double quotation marks, you would get an error and it would not be very happy with you. I try to remember that single quotation marks or apostrophes by knowing that there's one thing inside of a char. So since there's one thing inside the char, I only need one little mark to show that I'm storing something in there. The next data type that we want to talk about is known as a BOOLEAN. Now, I know it sounds kind of weird, but BOOLEAN. It's used to represent a true or false situation. It's named after a Robert Boole, actually. There's an entire branch of mathematics based on his information. So particularly, we're going to use this when we're determining blocks of code to run. So I have a Boolean that I've made here. Notice it's called Boolean is Friday, and I set it equal to true. So notice the true and false are the only two values you can assign to a Boolean variable. Now you're probably saying, that doesn't sound very useful, Marsh. Well, sometimes maybe you want to know if someone's a teenager. And if they are a teenager, you would set the Boolean equal to true. When we get into conditionals, aka if statements, sometimes they're a lot more useful in that regard. But keep in mind that that is available to us. Again, though, look at how we create this variable. It is a data type, name, equal sign, value if we wish, semicolon. I don't need this second half. I could just put a semicolon here, and what would happen is that the is Friday variable would be assigned a default value. In this case, for Boolean, it is a false value for a default. So if you don't give or initialize a variable right at the start, he does get a value. It's just not necessarily the one that you would want it to start with. The next guy we want to talk about is strings. Now, he's kind of a little special, Mr. String. He is an object, and we'll get a little bit more information here in a minute what that means. But he is used to store a group of characters together, so we could store anything inside of this object of string. So you can store anything. I can store hello world. Now, again, I have my plug static void main. I have string, capital S. No, it's a little different there. S equals quotation mark, hello space world, quotation semicolon. I can then print out S. Now, string has to be capital. The reason for that designation is because he is an object. He is not a primitive data type. He doesn't just store one thing, he can store multiple things. Now, let's talk about the difference between primitives and objects. And this is kind of a weird thing to get into. And as we continue in this year, we'll continue to learn about objects and also create our own objects. But keep this in mind. So we got primitive data types are going to be stored in the same memory area versus an object has a reference variable. So here I made int age and I stored 15 inside of it. That is a primitive data. So this is primitive. Didn't spell that right. But nevertheless, now, if it's an object, such as a string, what's happening is there's two things being created. There is what's known as a reference variable, and then inside of that reference variable is a address pointing to where the information is actually stored. Now, this probably sounds kind of strange, like, well, why on earth would we do that? Well, it is to make it so that you are holding less data and less memory. Java was made in the 1960s, okay? Computers back then, they didn't have the memory capabilities that we have now. So we had to have the abilities to store things simpler. And in this case, this allowed us to store things simpler, especially if I would have another string that's also has marsh inside of it. This information right here could be used for two separate variables. So keep this in mind that there is a difference. Now, does that make a difference for you when you're making these variables? No, there is no difference. However, keeping in mind that that is different when you're making them will help you as you continue in this Java experience. So, when we are saying something like double x equals 1.6, we're actually doing two things at once. We are declaring x to be of type double, and we are initializing x to be a value of 1.6. So this is declaring and initializing. This part right here is the declaration, and this is the initializing. If you think about it, initial is an initial value. How much are you starting out with? That's what initializing does. Okay, you can do this on 2 lines of code. I don't know why you would. However, you can accomplish said task. I can declare on 1 line. And let's say I don't know the value of x right away, so I could put quite a few lines of code in the middle, and I could say near the end, you know what? I know x value should be 1.6. This is me giving the value or initializing the value of x. So keep in mind, you don't have to initialize right at the beginning, especially if you don't know the number for it. And a lot of times, you're not going to know the number for your variable right at the start of your program. Now, you're probably asking, well, what is something that could be causing a problem? What's legal for us? Well, it's illegal to put a decimal inside of an int. So right here, I got an example of what's illegal. Int ARWS equals 47.4. Now, again, remember, let's go back. Int is the no decimal club. No decimal is allowed. So this one, I can't put 47.4 is. This is illegal because a decimal number cannot fit inside of an integer variable. There's not enough data, enough bits to be stored for that variable. So keep that in mind. It will not round. It will literally cause an error on your program. Now, the flip of that, 103 inside of a double is fine because I can just say this is 103.0. That's fine. So I can put an integer inside of a double because it's not as small or not as big as a double. But I cannot do the flip. I cannot put a double inside of an integer. I know it's confusing, but just remember, doubles for decimals, they're both D. That helps us remember which one is for which. Now, there are some rules for variables names. A variable name must begin with a letter or an underscore, and it cannot contain any spaces. Now, what does that mean? No numbers to begin. Okay, so I can't start a variable with a number. And it's really kind of annoying. Sometimes I find myself wanting to do that, and then I get an error and I'm like, I forgot that that's not available. Okay, so keep that in mind. No punctuation unless it's an underscore, and no keywords. So I can't use the word main, int, double, stuff that Java is going to turn blue. Okay, so here's some examples of legal. I can go argro at D31, hopper G, hopper underscore G, large area, gold nugget. Can't do 139, starts with numbers. 139 ABC still starts with numbers. There's a space here. Class is a keyword. Can't do that. Slow dot Sally. Can't do a dot. Double, that's a keyword. Can't do it. No semicolon, no hyphen. Just be careful when you name your variables. A lot of times your variables are going to be one word, like age or number of feet or something along those lines. You're not going to be doing multiple words. However, sometimes you find yourself needing to accomplish that task. If that's the case, that's okay. A lot of times what students will do is what's known as camel case. So for this hopper G here, what I would have done is hopper and then capital G E E. That is allowing me to be able to see what's the next new word. Kind of like how large area has a capital A, it makes it a little easier for our eyes to see that second word of the variable's name. That's the end of this video. Again, we're just going to be continue practicing. This is something that's going to be an integral part as we continue our programming. So we will continue and put this into practice in the next couple of days. Until then, I'll see you later, Sabers.